Hello and welcome to this session. Did you know that we can create complex logic systems using simple parts? One essential part is the NAND gate. It does a NOT AND function. When you understand how to make other basic gates from NAND, you'll see how we can build any digital logic complexity. Let's check it out.
Objectives. At the end of this session, you will be able to construct AND or NOT gates using NAND gate, realize and verify the truth table of AND or NOT gates using NAND gate along with switches and LED. Let's recap the concept of NAND gate. You have already learned that a NAND gate is a type of universal logic gate that one can use to realize any kind of logical expression or any other type of logic gate. It is a combination of two basic gates, namely AND gate and NOT gate. A NAND gate is a type of logic gate whose output is low when all its inputs are high, and its output is high when any of its inputs is low. Therefore, the operation of the NAND gate is opposite that of the AND gate. Now, let us explore how AND or NOT gates can be built from NAND gates. For this, you will need the following tools and equipment such as regulated DC power supply 0 to 30 volt 3 amperes 1 number, digital multimeter with probes 1 number, wire stripper 1 number, nose plier 1 number. We will need the following materials and components: breadboard 1 number, IC 7400 1 number, miniature toggle switches 2 numbers, hookup wire as required, resistor 330 ohm 1/4 watt CR25 1 number, and LED 5mm 1 number. Let us now dive into the procedure of construction and testing of AND gate using NAND gate with IC 7400 and verification of its truth table. Before proceeding to the hands-on procedure, let us now look at the logical circuit. First, connect two inputs A and B to a NAND gate. Take the output of that first NAND gate and connect it to the inputs of a second NAND gate. The output of the second NAND gate will now function as an AND gate for the inputs A and B. Since NAND gate outputs are low only if both inputs are high, connecting two NAND gate outputs sequentially results in a high output at the second gate only if both inputs A and B are high. This gives the same logic as an AND gate. Let us now look at the procedure. Collect all the required components. Check them. Ensure the resistor and LED are in a working condition using a multimeter. This includes a 7400 IC, breadboard, power supply, toggle switches, resistors, and LED. Once you've got everything, mount the 14-pin IC firmly on the breadboard. You can also refer to the circuit diagram for accuracy. Connect linking wires from the power supply to the breadboard. Next, connect 14th pin of the IC to the plus 5 volt power supply. Then, make sure pin 7 is connected with the ground. These connections are vital for providing the necessary power and establishing a common reference for the circuit. Moving on to the inputs, connect both terminals of the toggle switches to the power source and ground. And connect switches S1 and S2 to the first and second pin of the NAND gate. And the output at pin number 3 is connected to both 4th and 5th pin of the same IC. Now, let us set up our visual indicator. Connect a resistor to the output pin number 6 of the IC. This will limit the current to the LED, protecting it from burning out. Then, attach the anode of the LED to the free end of the resistor and cathode to the ground. This will help us see the result of our AND gate's output clearly. Before you power up, get your assembled gate circuit checked. This is crucial to avoid any short circuits or incorrect connections that could damage the IC or affect the functionality of the circuit. With everything checked, switch on the 5 volt DC supply. Begin the test by operating switches S1 and S2. Check if the toggle switches S1 and S2 are in the low state. This indicates 0-0 combination. For this, let us verify the LED. It is not glowing. Now, toggle the switches to 0-1 combination. Verify the LED. It is still not glowing. So, we know that if any of the input is 0, AND gate produces the output 0. Now, toggle the switches to 1-0 combination. There is no change in the output state. The LED is not glowing. Finally, toggle the switches to 1-1 combination. You may observe now that the output LED is glowing. The next procedure is the construction and testing of OR gate using NAND gate with IC 7400 and verification of its truth table. Before proceeding to the hands-on procedure, let us look at the logical circuit. First, connect input A to a NAND gate. Connect input B to a separate NAND gate. Connect the outputs of those two NAND gates to inputs of a third NAND gate. The output of the third NAND gate will function as an OR gate. Inputs A and B are fed into separate NAND gates first, which invert the signals. By then NANDing these inverted signals in a third gate, the cascade of NANDs serves to invert the inputs twice, reconstructing an OR logical function. Collect all the required components and check them to ensure the resistor and LED are in a working condition using a multimeter. This includes a 7400 IC, breadboard, power supply, toggle switches, resistors, and LED. Once you've got everything, mount the 14-pin IC firmly on the breadboard. Use the circuit diagram for reference. Connect linking wires from the power supply to the breadboard. Next, connect 14th pin of the IC to the plus 5V power supply. This is our VCC, the lifeblood of the IC. Then, make sure pin 7 is connected with the ground. These connections are vital for providing the necessary power and establishing a common reference for the circuit. Moving on to the inputs, connect both terminals of the toggle switches to the power source and ground. And connect switches S1 to the first and second pins and S2 to the fourth and fifth pins of the NAND gate. The output obtained from pin numbers 3 and 6 are fed to the 9th and 10th pin of the IC as input, and output is obtained from pin number 8. Connect a resistor to the output pin number 8 of the IC. Attach the LED as well. With everything checked, switch on the 5V DC supply. Begin the test by operating switches S1 and S2. Check if the toggle switches S1 and S2 are in the low state. This indicates 0-0 combination. For this, let us verify the LED. It is not glowing. Now, toggle the switches to 0-1 combination. Verify the LED. You may observe now the output LED is glowing. So, we know that if any of the input is 1 or both are 1, OR gate produces the output 1. Now, toggle the switches to 1-0 combination. There is no change in the output state. The LED is glowing. Finally, toggle the switches to 1-1 combination. There is no change in the output state. The LED is glowing. Finally, let us view the construction and testing of NOT gate using NAND gate with IC 7400 and verification of its truth table. Let us look at the logical circuit. Connect the input A directly to the NAND gate. Since a NAND gate inverts the inputs, connecting the input directly to the NAND gate achieves the logical NOT function. Let us now look at each step in detail. Collect all the required components. Ensure the resistor and LED are in a working condition using a multimeter. Once ready, mount the 14-pin IC firmly on the breadboard. Connect linking wires from the power supply to the breadboard. Next, connect 14th pin of the IC to the plus 5V power supply. Then, make sure pin 7 is connected with the ground. These connections are vital for providing the necessary power and establishing a common reference for the circuit. Moving on to the inputs, connect the toggle switch to the power source and ground. And connect switch S1 to the first and second pin as input A. Output is taken from the third pin of 7400 IC. Do not forget to connect IC output to an LED with a resistor. With everything checked, switch on the 5V DC supply. Begin the test by operating switch S1. Check if the toggle switch S1 is in the low state, that means 0. The output turns to 1, that means LED is glowing. If the toggle switch S1 is in the high state, that means 1. The output turns to 0, that means LED is not glowing.
This brings us to the end of this session. In this session, we have learnt how to construct AND, OR and NOT gates using NAND gate IC and realization of AND, OR and NOT gates using NAND gates and verify with their truth tables. Thank you for watching. We will see you in the next session.